Alright, here we have problem number 42. We have a high-speed train in red and a locomotive. The train is moving at 161 kilometers an hour, and the locomotive is moving significantly slower at 29 kilometers per hour. And when they're on the same track, they are 676 meters apart. The first thing we're going to do is convert from kilometers an hour to meters per second. We're going to do that for both of those so we can work in standard SI units. Next, we're going to realize the position-time equation for each of the objects, the train and the locomotive. And it's the same equation, but keep in mind that the initial velocity, or the initial position as we've chosen it, for the train is 0. And the acceleration of the locomotive is 0 as well. When they just miss each other, the position of the train and the position of the locomotive will be the same, and the velocity of the train and the velocity of the locomotive will be the same as well. If you wanted to be specific about it, the positions will be slightly different, but as the limit goes to 0, you could say their position is exactly the same. If, when their position is near each other, the train was moving faster than the locomotive, they would still hit eventually. If the train's moving slower than the locomotive, then they'll never hit the same position. Both of those things must be true. Then we're going to do a velocity equation, realizing the velocity of the locomotive must equal the velocity of the train. The locomotive's velocity is constant, where the train's velocity is changing with acceleration and time. Then we write the position equation, setting those equal to each other. The initial velocity of the train times time plus 1/2 AT times time squared equals the initial position of the locomotive plus V0 LT. Finally, we solve for the acceleration of the train. We solve the velocity equation for the acceleration of the train when they're at the same position and when they're going the same velocity. And the reason we solve for acceleration here is because when we get to the acceleration term in this solution, one of the times will cancel out. So that will change this from being a quadratic, which will significantly simplify our solution. So we're initially going to solve for time. So in the next page, I'm going to have I'm going to redraw each of these equations so we can see where we go. But from this point, we are just going to, 1, have time. That is, we're going to factor out time from the equation. And then we're going to basically solve, well, first we're going to move all of the time terms to one side. We're going to factor out time. And then we're going to solve the equation for time. So here we have the equation in black, where time is on one side. Then we factor out time. And then we basically solve the equation for time. Only then do we put in our numbers. And solve for the time is 36.87 seconds. And the acceleration is negative 0.9943 meters per second.